We can also apply the concept of the molarity of a solution to something we learned before when we were looking at ionic compounds such as calcium chloride. Remember, if an ionic compound is soluble in water, it dissociates into its cations and anions. So calcium chloride is soluble and will form the calcium 2 plus cation and 2 chloride anions. So when we have an original molarity that's 0.40 molar, that doesn't mean that the concentration of the ions are also necessarily 0.40, because we have to look at the stoichiometry between this reaction. It's a 1 to 1 to 2 ratio. So every one of the original calcium chlorides is going to form one calcium, but it's going to form twice as much chloride, which means the concentration of calcium will be the same as the original calcium chloride, so that will be 0.40 molar. But the concentration of the chloride will be twice as much because of that 1 to 2 ratio. So this is going to be 2 times 0.4, or 0.80 molar. We can also dissolve gases in water. And you can think about something you already know about, such as a soda, which has dissolved carbon dioxide. So carbon dioxide normally would be a gas, but we can make it dissolve in the soda. And under what conditions will more carbon dioxide dissolve? And if you think about pouring out a soda, when you pour out a soda into a glass, the foam is the carbon dioxide leaving the aqueous and turning back into carbon dioxide gas. So the more foam you have, the less soluble the gas is. So when does a soda foam more? It's going to foam more when the soda is hot. So to make a gas more soluble, we want cold temperatures, which is the opposite of most things. If you're trying to dissolve sugar in water, if the water is cold, less sugar dissolves. Hot water can dissolve more sugar. But for gases, it's just the opposite. The gas is more soluble when the water is colder. And the other variable that we can control is the pressure. If you open the can of soda, you lower the pressure and you start seeing the dissolved carbon dioxide coming out of the solution. So to make it more soluble, we want the temperature to be low and we want the pressure to be high. High pressure means we have more dissolved gas.